Hello friends, welcome to a fresh new episode of our channel RG Innovations. If you have not subscribed already, please subscribe to our channel, click on the bell button and select all to get all future notifications of our video uploads. In today's video, we are going to discuss about DS1307 real-time clock module. We will know all its features, functions, and how to interface with an Arduino and how to set and get the time into this module. In my previous video, I have discussed about DS1302 module. If you want to view that, I'll give the link in the description as well as in the I button, so you can check that out. So without wasting much time, let us discuss about the DS1307 RTC module. The DS1307 is a popular real-time clock module built around the highly capable DS1307 RTC chip and the AT24C32 EEPROM, used in electronic projects to keep track of time even when the system it's connected to is turned off or restarted. It is commonly used with Arduino and other microcontroller-based projects to maintain accurate timekeeping. Let's learn about a brief overview of the DS1307 RTC module and its typical applications. First, let us look at the clock functions. Timekeeping. The DS1307 maintains time through a 32.768 kHz crystal oscillator, tracking seconds, minutes, hours, day of the week, date, month, and year. 12-24-hour format. It supports both 12-hour and 24-hour formats. The 12-hour format has AM/PM indication. Leap year compensation. The DS1307 automatically accounts for leap years up to 2100. Setting and retrieving the time. You can set and retrieve the RTC's time and date through a microcontroller using the I2C protocol. Battery backup support. The DS1307 can continue keeping the time when the main power source is lost via backup battery, commonly a CR2032 coin cell. Power consumption. The DS1307 is designed for low power consumption, allowing the backup battery to last for a long time. It automatically switches between main power and battery backup when needed. I2C communication. The DS1307 communicates with the microcontrollers through the I2C interface using SDA, that is serial data line, and SCL, that is serial clock line, for data transfer. Now the communication interface. We just said that the DS1307 real-time clock uses I2C communication interface for data transfer between the RTC and other devices such as microcontrollers. Now what is I2C? I2C is a multi-master, multi-slave serial communication protocol designed for low-speed data exchange between devices. It uses a simple two-wire interface and supports multiple devices on the same bus. It takes up two addresses. The DS1307 RTC's chip fixed I2C address is 0x68 and the AT24C32 EEPROM's fixed I2C address is 0x50. Wiring. The two wires in I2C are SDA, that is serial data line. This line carries the data between devices, and SCL, that is serial clock line. This line provides the clock signal for synchronizing data transfer. Pull-up resistors. I2C typically requires pull-up resistors on both the SDA and SCL lines to ensure signal integrity. To enable communication, both the SDA and SCL lines have 4.7K pull-up resistors. Power and backup. Voltage range. The DS1307 operates on a main power supply of 4.5 volt to 5.5 volt, making it compatible with common microcontroller platforms. Power source. This power is generally supplied from the microcontroller or an external power source. Battery type. DS1307 uses a small battery, that is a coin cell battery like CR2032. Battery life. The DS1307 consumes very little power in backup mode, so the backup battery can last for several years. Automatic power switching. The DS1307 automatically switches to the backup battery when the main power source is lost. This seamless transition ensures that the RTC continues keeping the time without interruption. Typical current draw. The current draw in backup mode is around 300 nanoamps, which is why the battery lasts for a long time. Data retention. The DS1307 has 56 bytes of battery-backed RAM, which can also retain data during power outages. Now let us learn about the DS1307 RTC chip. In the picture, we can see this is the DS1307 chip. At the heart of the module is a low-cost, extremely accurate RTC chip from Maxim, that is the DS1307. It handles all timekeeping functions and communicates with the microcontroller over I2C. The DS1307 requires an external 32 kHz crystal for timekeeping. This is the crystal 32 kHz, the frequency of which is easily affected by an external temperature. Even though these changes in frequency is negligible, it does add up. It might seem like a problem, but it's not. It actually causes the clock to be off by about 2 minutes per month. Now the battery backup. DS1307 IC incorporates a battery input for maintaining accurate timekeeping even when the device's main power is interrupted. The built-in power sense circuit continuously monitors the status of VCC to detect power failures and automatically switches to the backup supply. This means that even in the event of power outage, the IC can still keep time. For backup power, the module has a holder of 20 mm 3V lithium coil cell at the back side. Any CR2030 battery will fit nicely here. Assuming you use a fully charged 47 mAh coin cell battery and keep the chip current draw to a minimum of 300 nanoampere, the battery should be able to power the RTC for at least 17 years without the need for an external power supply. The DS1307 RTC module also includes a 32 kilobit, that is 4K into 8 bits 8024C32 EEPROM non-volatile chip with about 1 million write cycles. This chip doesn't really have anything to do with the RTC, but it can be useful for things like data logging or storing any other data that you want to be non-volatile. The 24C32 EEPROM communicates via I2C and shares the same I2C bus as DS1307. The onboard 24C32 EEPROM has a fixed I2C address of 0x50. The 8024C32 EEPROM is rated for 1 million write cycles, so it won't wear out during normal data logging applications as long as you are not writing data every second. This is the 8024C32 chip on the RTC DS1307 module. Now we will talk about a hidden secret of DS1307 which very less people know, that is DS18B20 temperature sensor placement. The DS1307 RTC module has a provision for installing a DS18B20 temperature sensor that often goes unnoticed. The DS18B20 can be installed using the 3 mounting holes. If you closely see the module, you will see this portion written U1. This is the place for DS18B20 sensor. You will be able to obtain temperature readings from the DS pin. These readings can be used to compensate for temperature based time drift. Solder the DS18B20 according to the polarity shown on the silk screen. You may also require a 4.7K resistor between VCC and DS. So enough of theory. Now we will see the pinout diagram of the DS1307 RTC module. First, let us look at the right side. The first pin is SQ pin or SQW pin. SQW pin outputs one of 4 square wave frequencies: 1 Hz, 4 kHz, 8 kHz or 32 kHz. To select and configure the square wave frequency, you need to interact with the DS1307 via the I2C interface. Then comes the DS pin. DS pin should provide temperature reading if a DS18B20 temperature sensor is installed using the 3 mounting holes in the upper right corner, close to the battery holder marked U1 that we have seen a little earlier. Now the SCL pin. SCL is a serial clock pin for the I2C interface. Then the SDA pin, that is serial data pin for the I2C interface. Then the VCC pin for the positive power supply. You can connect it to a 5V power supply. And then GND pin, that is the ground pin. BAT is a backup battery input for any standard 3V lithium cell or other energy source to keep the accurate time when the device's main power is interrupted. That is, when we do not install the backup battery in the module, we can connect an external battery connection to this battery pin. And then at the left side, the same DS pin, SCL pin, SDA pin, VCC pin, ground pin. It's same as these pins, but it is used for daisy chain. That means if we want to connect any other I2C module, we can chain it from these connections. Now the circuit diagram. Circuit diagram is very easy. If we are using an Arduino Uno, we will connect the VCC pin from the 5V pin, the ground pin to the ground pin of the Arduino, the SDA pin to the analog A4 pin, that is the SDA pin of the Arduino, and SCL pin to the A5 pin or the SCL pin of the Arduino. This is the connection. And now we will look into the Arduino Sketch, then we will see the practical demonstration. So here is the Arduino Sketch. First we have included a library, that is Bonzegi DS1307 library. I'll give the library link for downloading. You can download and install it. Then we have created an object RTC with this library and given the I2C address of the RTC module. Then in the setup section we have started serial communication and initiated the RTC. Then we have set the format of the date, it's 12-hour format. Then we have set the AM PM. For AM it's 0, for PM it's 1. Then we have set the time, then we have set the date. This much only needed for setup, and then in the loop section we have printed all the data into the serial monitor. You can, if you just study it a little, you will understand it yourself, so no need to explanation. Then if gate format is 12, print AM and PM accordingly. And this is the same function that we used in our last project. It's a 2-digit conversion number. If the date or time is in a single digit, it will convert it to 2-digit with a leading 0. So this is the program. Now we will connect the Arduino with the computer and upload the sketch. So this is our circuit diagram. We have already shown it. We need not to discuss it much. This is the RTC module. I have already shown in the picture, and now I am showing you the real module. So we have connected it with the Arduino Nano. Instead of Arduino Uno, we are using Arduino Nano here. You can use any version of Arduino that is available with you. Now we will upload the sketch and see the output in the serial monitor. You can see Arduino Nano on COM3. Now we will set the date to the current date and time. It's 04/05/2024 and the time is 11:09:30. Everything done. Now we will upload the sketch. Now let's open the serial monitor. You see, the time is showing properly, date and time with AM. So our first application is done. It is very simple. Till now, if you feel any confusion about this project, please feel free to ask me in the comments. I'll definitely try to clear your confusion. Now we will move on to connect an LCD display, I2C LCD display that we have also used in our previous project, previous video also. So instead of the serial monitor, the time will be displayed into the LCD display. First, we will see the circuit diagram. Then we will move on to the Arduino Sketch and then the practical demonstration. One thing I forgot to show you, that if I remove the power, I am removing the main power from the circuit. You can see board not connected, and then if I connect it again, the time counting has started without fail. But you see, one problem is there. The time has started where we have initiated the time. It did not resume the actual time. It is because when we restarted the power, the setup code once again executed and it initiated the time with the setup time we have mentioned. So we need to comment out the time initiation in the setup section and re-upload the code again. Then we will see. Now we will comment out this date and time setup section and re-upload the sketch again. Now you see the time count is proper, and if we remove the main power supply, it will not hamper the execution of time. When we reconnect the power, it will automatically show the correct time. So this is it. Now we will move on to the next demonstration. So here you can see the circuit diagram. This is the Arduino. The connection is same for the DS1307 module, and since both the devices are I2 devices, connection will be same for both the devices. The I2C LCD also will be connected to the analog pin A4 and A5 for SDA and SCL, and for VCC and ground it will be connected to the 5V and ground pin. So connection is that simple. Now we will move on to the Arduino Sketch and then we will see the practical demonstration. Now this is the Arduino Sketch for displaying the result into the I2C LCD. Here we need 3 libraries. One is Bonzegi, another is Liquid Crystal I2C, another is Wire.h. Wire.h need not to be installed separately. It comes with Arduino itself. You would require these 2 libraries separately. I'll give the link for download. Now we have created 2 objects. One is RTC, one is LCD, given the I2C address of the RTC, and this is the I2C address of the LCD, and this is the size of the LCD, that is 16:2. Now in the setup section, again we have initiated the RTC module. Then we have initiated the I2C communication with the LCD. First we have made a check whether the LCD is found or not. Then if LCD is found, LCD will be initialized. Then in the loop section, all the date and time will be printed into the LCD. Then you know this function, this is the 2-digit conversion of the date and time with the leading 0. So this is the program. Now we will connect the Arduino and we will see the practical demonstration. Now here the connection is done. We have connected the RTC module, we have connected the LCD module. This is a pen I have given below it because it is otherwise tilting. So it's connected with the same connection, that is both the modules SDA to A4 and both the modules SCL to A5 and VCC to 5V ground to the ground pin. Now we will give power to this module, connecting it with the computer. The LED display is turned on. Now we will upload the sketch. So we are splitting the screen into half and half so that you can see it, the code execution and the output in the screen. So I'm uploading this sketch. You see, as soon as the uploading is complete, the date and time is showing here. I forgot to change the date and time in the code, so it's showing the old date and time that is already written in the code. Otherwise it is functioning properly. So making it full screen, you could see that after 12 it changed to PM. Now I will show by removing the power if it retains the time and it can recall the time. So I removed the power, main power. The backup battery is already there in the module. This backup battery is there already. Now I am connecting it back. You see one thing, that when I reconnected the power, it has started the old time because it is executing the setup section again. So it is taking the time that is given in the setup. So we will do one thing, we will remove the time from the setup. Let's get to the screen. We will comment out this section now and then upload the sketch again. This time you see it started the time from so far it has executed. Now if we remove the power and if we reconnect it, it will show the proper time. So one thing you remember, before making your final project, do not forget to comment out the setup section date and time. See, I remove it, remove the power and reconnect. It will start from so far it has executed. So I hope you have understood how to use the DS1307 module with Arduino and LCD display. It is very simple. The circuit diagram is also very simple. Still, if you have any further confusion, please feel free to ask me in the comments. I'll definitely try to clear your confusions. So today I am concluding here. We will meet again in a new video. If you like my video, please hit the like button and do not forget to subscribe my channel RG Innovations. Bye bye. Thank you for watching. Have a nice time.